So let's talk about eccentricity of hyperbolas, which is actually very similar to eccentricity of ellipses. So to calculate the eccentricity, it's still c over a, just like ellipses. So as far as like how you interpret it, so first of all, I just want to note, so hyperbolas will always have an eccentricity greater than 1. So if you're getting something that's less than 1, that means that there's something wrong with your calculation. But the closer the eccentricity is to 1, the narrower the graph will be, versus like if you have like a really large e, say like 70 or something, you're going to have a super wide hyperbola. So just, a couple of exercises just to kind of drive this home. So find the eccentricity. Okay, so I've got this hyperbola. I can tell it's a hyperbola, by the way, because it's got the minus sign. So that's like the huge tip off that you've got a hyperbola. Okay, so in this case, I'm going to calculate my c squared equals a squared plus b squared. Now, by the way, I find it is easier for me to remember the eccentricity equations for hyperbolas and ellipses, or sorry, the c equation, because it's always the opposite sign. So this is a minus and then this is a plus. So that's like a little hack you can use to remember them. Okay, so anyways, so this is going to be 30, c squared equals 36 plus 9. So c squared is going to equal 45. So, okay, my c then is just going to be the square root of 45, which I guess I could rewrite as 3 square root of 5. And then I have to calculate my eccentricity, which is c over a. So this is going to imply that my a equals 6, by the way. So this is going to be 3 square root of 5 over 6. And so this can be simplified then to square root of 5 over 2. Okay, so to calculate the eccentricity for this next problem, so the first thing that we want to do is we need to get this into the standard form. So I first want to divide everything by 16, since this whole equation equals 16. So then I can simplify this to y squared over 2 minus x squared equals 1. And I'm going to put that x squared over a 1 just so that I don't forget that there's like an invisible number there. So then my c squared is going to equal 2 plus 1. So remember, these forms of these numbers, this is already a squared. This is already b squared. So you might have this temptation to square these things, but remember, like in the setup of this equation, these are already meant to be squared versions. So I just take c squared equals 2 plus 1. So my c squared equals 3. Therefore, my c is going to equal the square root of 3. So when I go to calculate my eccentricity, I will have the square root of 3 over the square root of 2. Okay, and then the last thing I want to talk about is just how do you write the equation of a hyperbola using eccentricity. So find the equation of a hyperbola with e equal to 25 over 9 and foci at 9, -1, and -11, -1. So of course, you know that I am going to tell you to start with graphing this a little bit. We don't have to graph it all the way, but just to kind of wrap our heads around it. So I'm not even going to draw a great graph. So I'm just going to approximate. So here's my here's my 9, not -9, 9, -1. And then here's my, put it right here. Here's my -11, -1. So if my foci are here and here, these are going out from the x direction, right? So that's telling me then my hyperbola goes in this direction. And okay, so that, like, I can get a lot of information off of that. So that tells me that I'm going to have x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, so probably the next thing that we'd want to do here is we'd want to figure out what is the center of this equation, or for this hyperbola. So let's see. Let me just get rid of these little fake arms I put in. So these go out both a direction of c from one another, right? So we need to know what is this distance. And so to calculate that, I can just take 9 minus negative 11, and I see that that's 20. So the total distance here is 20. So if I go in the middle of that, so if I divide that in 2, then that's going to equal my C. So if this whole distance is 20, remember you start from the center and then you go out 10 in each direction. So one, I've just figured out what my C is. So I'll note that here. My C is equal to 10. Additionally, I can also now figure out what my center is. So if I want to take this negative 11 and then so if I want to start here and then just move it forward 10 to the right, I can just add 10 to this. So notice how I took this focus point and I took this distance in between, and now I'm just moving it to the midpoint. So I added 10 to it. So this is going to be negative 1, negative 1. So there's my center. So, okay, so that's really good. I figured that out. I also figured out C in this. So now I can bring that in with my eccentricity. Okay, so eccentricity is normally calculated as C over A. And we know that this equals 25 over 9. But now we know something a little bit more specific about C. We just figured out that C is 10. So remember, these ratios, the way that they state them, they're literally meant to kind of throw you off and not be like it's never going to be, oh, C is 25 and A is 9. It's like never going to work like that. These are literally meant to be not the right number so that you kind of have to back into it. So that's like a big hint for you, by the way. So, okay, so I've got 25 over 9 equals 10 over A. So once I boil this down to one variable, then I can solve it no problem. And so this is going to give me that 25A equals 9 times 10. Okay, let's see. Let me get rid of all this here because I'm running out of space. So let's see. So now I've got, actually, let me restate this. So I have x plus 1 squared over a squared, and then y plus 1 squared over b squared equals 1. So that's kind of where we are. So I just want to state that so that I can make some more room for myself by getting rid of this. Okay, so now, so I was at 25a equals 90. Therefore, a equals 90 over 25. So that's going to be 18 over 5. And so now you can see this is kind of like going to be some wacky numbers that we've got to deal with. Now I know my C, I know my A. So if I've got this C squared equals A squared plus B squared, this is going to be 10 squared equals 18 over 5 squared plus B squared. Now I'm just going to do the algebra to figure out what is B squared going to equal. So I'm running out of space here, so I'm assuming you can do the algebra on this. And are you ready for this insane number? So I would, by the way, I would try to keep all of this in terms of like fractions. So B squared is 2,176 over 25. Yes, I know it's a crazy number, but it is right. Okay, so now let me clear some space. And okay, so I can fill in the rest of this. So I've got x plus 1 squared over, let's see, I need to do 18 over 5 squared. I do already have my b squared, so that's cool. So this is going to be minus y plus 1 squared over 2176 over 25 equals 1. So I talked about this trick actually, I think in my last equation writing video. So, okay, so this becomes x plus 1. So let's see, 18 squared is 324. So let's see, this is 324 over 25. So you've got this like really crazy looking equation. So the way that you make it look just like slightly less crazy is now you take the reciprocal of these fractions so that you don't have this like fraction within the fraction. So the final answer here is 25x plus 1 squared over 324 minus y plus 1 squared minus 25 y plus 1 squared over 2,176, and that all equals 1. Okay, and so that brings us to the end of that video. So I will catch you guys in the